Good afternoon. My name is Chris Henderson. I am the General Manager of Jeffries Engineering here in Australia. Thank you to Philsutech for the invitation to speak this afternoon, and congratulations on running yet another successful conference, and especially a virtual conference in this difficult global environment. Thank you to everyone for your time. I'm just going to take a few minutes to talk about JEFFCO technology and its use for highly accurate payment systems. A sugar laboratory in a sugar factory is a crucial piece of infrastructure. A high-functioning, high-quality sugar laboratory can make a sugar factory a lot of money. How does it do this? Well, it does this by providing accurate, on-time analysis. It provides good data to the process, and it explains that data well. Whilst sugar is extracted from the sugarcane by the process engineers, it's the laboratory's job to tell and confirm to the process engineer where the sugar is, how much sugar there is, and if the sugar engineers are being successful in getting all of that sugar out of the sugarcane. But there's more. It's more complex than that. It's not just about sugar these days. Factory payment systems rely on the laboratory accurately determining how much sugar is in each sugarcane delivery coming into the factory. Payment used to be simple. It used to be about bricks, pole, and weight of cane. Now, in a cane quality measurement, it potentially includes fiber, trash, soil, and sand, and other components. A global trend towards mechanical harvesting means higher soil, sand, and trash levels coming into the factory in increasing proportions. So how does a sugar factory in this more complex sample environment accurately determine cane quality? Reducing transport costs requires more cane in each delivery and less soil, sand, trash, and other non-valuable components. So feeding accurate data from the factory back to the agronomy sections and the harvesting sections is important, because that feedback loop can iteratively improve cane quality over time. Sugar factories are developing, and an expanding range of products that sugar factories work with these days mean that there are more testing for the sugar laboratory in other products. For instance, biomass, bioproducts, cogeneration, and if industrial clustering occurs, where manufacturing processes are co-located next to or near or in the sugar factory, then the sugar laboratory can get involved in testing of packaging materials, new chemicals, plastic, paper manufacture, and so on. More complex process engineering in the factory means more complex process sampling and testing by the sugar laboratory. Basic errors in the sugar laboratory in this more complex world are more common than you think. And these can include irregular or no equipment calibration, unrepresentative samplings, poor sample preparation, sample handling mistakes, poor quality equipment, so buying the cheapest but not the best for the application, not enough samples being tested, so not a high enough frequency of testing, no auditing of the laboratory processes, and of course, probably the biggest error of all, the most challenging one, releasing results without a sensibility test. So let's talk about some examples. And one example I wanted to mention was hydraulic press. Hydraulic presses range in quality, and in fact, some sugar factories make their own hydraulic presses. And a hydraulic press, or a press, is designed to extract the juice from samples of shredded or prepared cane, so that juice can be analyzed for bricks and pole by the laboratory. Of course, unstable and inconsistent pressure applied to that sample can give you a poor quality juice extraction. And that can be caused by wear and tear or broken seals. Of course, if you apply the incorrect pressure applied, if you apply incorrect pressure, for instance, not following the Akumsa method, then you're not going to get all of the sugar out in that press. If the sugar press, if the hydraulic press or the press were to break down, of course, it would be repaired, but then the pressure changes could occur. And in an unautomated press environment, so where the press is manually operated, then you can get variable pressures applied, and that can be applied for variable times. It depends entirely on the operator. And of course, a hydraulic press uses a small sample, and especially if it's a single once only grab sample, then the question, of course, is that sample representative? So all of these things add up to variable juice quality in your extraction from that sample. And not all sugars are extracted. So of course, your Brix and your Poll analysis therefore becomes incorrect for that sample. And of course, those incorrect results for that sample doesn't represent that delivery of sugarcane that you've taken that sample from. So you might use 300 grams for a press, but there may be 20 ton or 20,000 kilograms or 20 million grams of natural and varied harvested variation in that truck. So the representation isn't there. Here's a couple of examples of locally made press. They're unautomated and the design hasn't been thought through carefully enough. Of course, there's no pressure indicators. There's nothing to indicate the pressure being applied to the sample. So you get variable pressure. Because there's no automation, there's no timings. So it relies entirely on the operator and the operator using his watch or a timer. Hydraulic seals can leak and not be noticed. And of course, ultimately, every sample is processed differently. There's no repeatability. So every result is different and not in a good way. The JEFFCO wet disintegrator is designed to provide a repeatable sample handling process. It has a water-cooled sample bowl, and this maintains the temperature of the sample at a constant temperature whilst the sample is being disintegrated. This means that there's no degradation of sucrose, no breakdown of sugars, and the sample analysis will be accurate. We get 100% cell breakage every time. It's an automated piece of equipment. So we put the sample in, we press the start button, and the sample will be processed. It saves time and resources, and importantly, it's a repeatable process. It's automated, it's repeatable. It conforms to Akumsa standards for larger samples, which means we get better representation. And of course, we're very strong on safety. So it has an incredibly, because of safety sensors, it has an incredibly low risk of injury for your operators. Let's talk about sample representation. So for instance, use some NIR technology, use a small sample size for analysis in a laboratory, perhaps 50 grams. That 50 grams has been taken from a truck, which might be 20 tons, 20,000 kilograms of natural harvested variation. So it's not a representative sample. 50 grams does not represent all the variation in a large truck full of sugarcane. Taking grab samples, taking one sample is, especially in a process environment, will give you a spot result, but it doesn't represent all the variation in that process environment. It's much better to take a larger number of smaller samples and combine those for that single analysis. That will give you a better chance of catching the variation in the process environment. And using benchtop equipment with small samples, again, gives poor representation. The result might be correct for that 50 grams, but in effect, it's a random number generator. You could take 100 50-gram samples from that one delivery and get 100 different results. Which one is correct? So what about sample handling? So there's some basic rules about handling samples in a laboratory environment. So when a sample is collected, you want to analyze it directly, straight away, without delay. So we minimize any sample changes or any sample degradation. We need a strong identification chain. We want to maintain the integrity and the identification of that sample from the start, when it comes into the laboratory, when it's collected, as it goes through the laboratory processes to its final analysis. And one way of doing that is to remove, as much as possible, human interaction in handling those samples. Laboratory information systems, especially electronic systems using barcodes or readable tags, RFID, can feed results directly from the lab technology into the factory network and factory databases. Again, removing human interaction and removing the use of handwritten notes and so on. Managing, evaluating, carefully thinking about how samples flow through the laboratory is also important. So you need to design the pathways for samples through the laboratory to minimize handling, to reduce time, to make sure that one sample doesn't corrupt another sample, you don't get contamination, and you don't swap or confuse identities. You need to only use the right equipment in the right order. It has to be a repeatable process. And of course, this is something that many laboratory managers don't evaluate often enough. You need to be looking at how this part works, because it's important in your sample handling and integrity. The JEFFCO Infracana, an NIR-based automated analytical technology, allows us to analyze a sample taken from a truck by a core sampler between 8 and 10 kilograms in about 90 seconds. We can get analytical results for bricks, pall, fiber, moisture, trash, soil and sand, extraneous matter, and many other parameters. It's a whole of sample analysis. We analyze 100% of the sample. So we capture all the variation in that sample. And because it's a larger sample size, maybe 10,000 grams versus 50 grams, it vastly improves the representation. It's repeatable. The sample follows exactly the same path. It's a short analytical flow path. And we can analyze that sample directly from the truck. We can use good validation practices to confirm the highly accurate performance of the Infracana. And because it's automated, we take the human out of the analytical process. So we minimize any problems. And it's highly visible. The sample is visible throughout the entire process. So in 90 seconds, we can achieve a minimum human interaction, highly accurate sampling with larger samples with better representation. So let's talk about sample preparation. So poor sample preparation loses sugar. And in the process environment, that can be a lot of sugar and a lot of value. In the process, a poorly performing factory shredder loses sugar and bagasse. We get a poor extraction from the sugarcane, and we lose sugar to the boilers. In the laboratory, a poor sample preparation means a lower measure of total available sugars. So the process engineers think there are less sugar than there really is in the cane supply. So we lose the opportunity of gaining that sugar. High-performing laboratories process and prepare the sample well, get complete 100% cell breakage, extracting all of the sugars for a reliable result. Importantly, the process engineers can rely on the laboratory figures. Poor shredder performance or shredder performance can be improved for better extraction and yield. For example, a 0.5 unit Paul error in the laboratory can mean higher extraction losses in the milling train. And that can mean $2,000 a day in lost income every day. The JEFFCO cutter grinder provides high preparation index, 95 or above, consistently and repeatably. Because of its careful design, we have a very low airflow whilst the machine is processing that sample. So therefore, with no moisture loss, we don't change the sample. Losing moisture means the sugar content as a proportion will go up in that sample. And of course, that means invisible sugar, sugar which you're saying is there, which doesn't actually exist. The cutter grinder, the JEFFCO cutter grinder, has strong safety features to minimize and remove the risk of injury. And it's reliable. We have examples in the Philippines which have analyzed more than 1.5 million samples, and they're still operating. So that has to be good value. And of course, we have local support in the Philippines for all of our technology. So let's talk about poor equipment design. And an example is the tumbler used for the measurement of preparation index. So preparation index, we're talking about a ratio of bricks in a factory shredder prepared sample against 100% extracted bricks from a sample. Some tumblers are too aggressive, and an example is the tumbler that you can see on the slide here. The sample containers are rotated end over end, and the sample moves aggressively from one end to the other quite violently, and that results in increased cell breakage in the sample. So of course, what that means is you're getting additional sugar extraction because of the way the sample is being processed through this tumbler. And that means that the laboratory will report a higher bricks value to the process engineers for the factory shredder than actually exists, which means invisible sugar, where sugar that doesn't actually exist, it isn't there, is reported. So the JEFFCO PT01 preparation index tumbler has been designed differently. It conforms to the ICUMSA method GS73 for preparation index. It is a gentle washing of the sample. The sample containers, the sample bottles rotate around the circumference of the bottle, so there's no aggressive washing, and that means no additional cell breakage. So the analysis of bricks and Paul taken and using the JEFFCO preparation index tumbler is much, much more accurate. It's representative of the performance of the factory shredder in this case. Let's talk briefly about supplier support. The cheapest investment in equipment often means either a poor quality equipment or poor support. And without support, the latest your equipment purchase can lose all of its value very quickly. And in this example, support means not only maintenance of that equipment, so having a supplier engineer or technician come and help you maintain that equipment, but it also means about application support. So how best to use that equipment for your application. It's a bit like buying a car and getting a really good deal, but if it breaks down and you can't get it fixed, or it struggles and it can't get you where you need to go, then in the end, doesn't matter how much money you spent on it, it's not a good deal. Briefly, laboratory audits. They're designed to validate good practices and to improve existing operations. But my experience is in the many sugar factories I've visited, laboratories audits are often seen as very bad things. And often, in some examples, a lab manager will take his best staff and use his best equipment to process the sample analysis. And of course, the results are predictable. The results are very good. That means there's no problems in the laboratory, no need for any improvements or any changes. Happy days. Audits should be your friend. It helps you find the next improvement. And improvements in a laboratory environment are iterative. We improve one step at a time. And of course, an audit isn't just about the sample analysis. It's about sample handling. It's about sample representation. Does it make sense that this small sample represents that large delivery of sugarcane? It's about workflows. How does a sample move through the laboratory? And is that process repeatable? It's about the opportunities for operator education and training. You can teach them more about what they're doing and help them understand the context. Of course, it's about conformity with ICUMSA and other formal official standards, methods of analysis. It includes equipment calibration and maintenance. And of course, it's the testing of your statistical validation processes. So control charts and other methods of checking that what you're doing is correct over time. It includes repeatability versus reproducibility. So the same sample measured with the same operators when the same equipment, or the same sample with different operators on different equipment. Finally, there's the sensibility test. And this is about always checking the sample results before they leave your laboratory. So the standard checks, is the result correct? Is the result accurate? But of course, check number 2 should be, does that result make sense? So an example might be, for instance, a Brooks result of 22, which sounds good. But if that is in a stream, a time period of Brooks values between 15 and 19, is 22 correct? It may be correct, but does it make sense? It may not make sense. So results leaving the laboratory without a sensibility test undermines confidence in the laboratory and invalidates all the other good work that that laboratory does. Cross-checking your results. So measuring or checking the result against your Paul and fiber values might help you confirm whether that result in this example is sensible or not. And this is where application knowledge is really important. So the more application knowledge, the higher the quality of your operators, your laboratory staff application knowledge, the more they understand the context of what they're doing, the more they'll be able to spot results which appear to be correct, but which just don't make sense. So what can we take away from this short conversation? Investing in high quality, well-designed laboratory equipment is a cost saving. Calibrate it and maintain it regularly. Examine your laboratory functions. Look for and aim for incremental improvements over time. What's the next improvement we can make? Training and education of your staff, applications knowledge, and context of what they're doing is really important. The better they are at that, the better their knowledge, the fewer the mistakes you will have occurring in the laboratory and the more sense you get out of everything that you do. External audits are your friend. Embrace them. It's an opportunity to find the next improvement. And saving a little in your laboratory by buying or investing in cheap equipment can cost you a lot out there in the sugar factory. Philosopher John Ruskin in the 19th century said, it's unwise to pay too much, but it's worse to pay too little. When you pay too much, you lose a little money. That's all. When you pay too little, you sometimes lose everything because the thing that you bought is incapable of doing the thing it was bought to do. So if you deal with the lowest bidder, it is sensible and wise to add something for the risk that you run. And if you add something for the risk that you run, you should have enough to pay for something better. Thank you for your time today. I appreciate that. If you have any questions, I'm happy to answer those questions for you. If you have questions after this, after today, please feel free to contact me at any time. Thank you.